IBESS, Soil and Terrestrial Food Production, Part 6, will introduce terrestrial food production systems with detail on the inputs and outputs. The essential ideas are, and there are three, the sustainability of terrestrial food production systems is influenced by socio-political, economic, and ecological factors. Secondly, consumers have a role to play through their support of different food production systems. And lastly, the supply of food is unevenly available, and land suitable for food production is unevenly distributed among societies, and this can lead to conflicts and concerns. Here is the first of two slides that outline the available movies in the Soil and Terrestrial Food Production unit. Use this outline to find the movie you need for review. This movie can be found on the next slide. Here is the second of two slides that outline the available movies in the Soil and Terrestrial Food Production unit. Use this outline to find the movie you need for review. This movie is right here. Natural capital is a resource found in nature that provides natural income in the form of goods or services. Our agricultural producer crops would be the natural capital, seen here as a stock. Through photosynthesis, carbon dioxide is taken up along with water to form organic matter, the organic matter of interest to people. The harvest of food, the carbon, energy, or nutrients from plants would be the natural income as a good. Here are people planting what will become the stock, the natural capital. This person is investing labor and seedlings as inputs to the development of the stock. Water would also be an input to the system. At some point in the future, the natural capital, in the form of rice plants in the paddy, will yield natural income in the form of grains to be harvested. Food comes to us from renewable natural capital because it's a living resource and because it can be harvested at rates equal to or less than rates of replacement. Here is a relevant IB syllabus statement. Renewable natural capital can be generated or replaced as fast as it is used. And examples of renewable natural capital would be anything living, food species, for example, surface water, groundwater, and the stratospheric ozone layer. Only a portion of the stock is harvested as natural income. In this example, the rice plants in the rice paddy constitute the stock, while the harvested grains constitute the natural income as a good. Remember to articulate stocks not simply as plants, but as stores of carbon, energy, or nutrients. Domesticated animals are also a significant source of food for people. So as we move through the food production unit, keep all trophic levels in mind, as well as the implications on energy flow. Domesticated animals as stocks have inputs of plants, and the population grows, and humans harvest a portion of the herd as natural income. The renewable natural capital that produces food as natural income could be cattle, pigs, chickens, or other animals. Here is an image of a hen house representing the natural capital of the agricultural system. The harvested eggs or chickens would be the natural income as a good. Food comes to us from renewable natural capital because it's a living resource and it can be harvested at rates equal to or less than rates of replacement. In this diagram, if we imagine the agricultural field or the hen house as the natural capital, the stock, the bowl would represent the stock. The flow, seen here as potentially sustainable, would be the natural income, the food we collect from our agricultural stocks. Soil is a very important component of agricultural systems. Plants that grow in agricultural systems are held by soil, and soil provides nutrients and water. The nutrients are made available to our agricultural plants by decomposers and nitrogen-fixing bacteria. Now remember, soil is non-renewable natural capital, and as a non-living resource, it cannot be replenished within a time scale at all similar to the rate at which it is taken. And as you evaluate whether or not agricultural systems are sustainable or not, remember the importance of soil in growing crops. If soil systems, as non-renewable systems, are not managed well, then our agricultural systems might not be as renewable as we imagine them to be. Here is the IB syllabus statement that drives the remainder of this movie. Terrestrial food production systems have inputs, outputs, and system characteristics with varying degrees of sustainability and environmental impact. Later movies will address sustainability and environmental impact. Before we look at the inputs and outputs of agricultural systems, let's be sure that we understand that different types of farms exist. The subsistence or traditional farm produces food for family use or local community use. The cash crop farm grows specific crops for market, crops chosen for the high current market price. The commercial industrial farm is a large-scale effort to maximize yields for profit-making purposes, possibly for export. The inputs and outputs of traditional farms will differ from that of industrial farms. Keep this in mind. Can you imagine the inputs and outputs of food production systems? Water, sunlight, seeds, fertilizers, pesticides. And the output? Harvested crop. I want you to think quantity and quality here. And what else? Eroded land, pollution, and the seeds of one year might become the start of next year's stock, an output that becomes an input. Here is a list of inputs to food production systems. Take some notes here, but keep in mind how inputs and outputs might differ between different farm systems. The industrial farm has a much larger fossil fuel input, while the traditional farm has a much larger physical labor input. Throughout this movie, keep thinking how inputs and outputs would be different among different food production systems. The output as a function of the input can be quantified in a value known as efficiency. Efficiency is output divided by input times 100. The more the output, the higher efficiency, but only if inputs remain low. Industrial farms have high output, but they also have high inputs. Thus, the efficiency of an industrial farm might actually be low. Traditional or subsistence farms with low inputs might actually have a higher efficiency than industrial farms, even though the output harvest on a traditional farm is lower than that on an industrial farm. Okay, let's begin with a look at the inputs to agricultural systems. Water is an input, rainfall or irrigation water from the ground. Water as rainfall is an input. Traditional farms more often use rainfall as their source of water rather than irrigation. Industrial farms use irrigation systems, often depleting groundwater resources. Keep sustainability in mind here. Fertilizer could be an input, inorganic, industrially produced fertilizer, or manure as an organic fertilizer. Now, which type of fertilizer is more likely to be used on an industrial farm, and which type of fertilizer would result in a more sustainable farm system? Seeds are an input, hybrid seeds or genetically modified seed. These types of seeds are likely to be found on an industrial farm. Indigenous seeds would be more likely on a traditional subsistence farm. Industrial commercial farms are more and more likely to use genetically modified organisms, seeds in particular. Herbicides and pesticides are inputs. Industrial or commercial farms are more likely to use herbicides and pesticides because these chemicals are expensive. Traditional farms cannot afford the cost of herbicides and pesticides. Traditional farms might use biological controls for pests, or traditional farms, by virtue of their greater diversity, may not need to actively control pests. Antibiotics that enhance the health of livestock are inputs on industrial, commercial, meat-producing farms. The organic farm movement chooses meat that has not been exposed to antibiotics. Hormones, much like antibiotics, enhance the growth of livestock. Again, the organic farm movement chooses meat that has not been exposed to hormones or antibiotics. Labor must be done in any food production system, but traditional subsistence farms use physical labor and more of it, relative to industrial farms that use more machines. Industrial farms use mechanical labor, such as tillers, harvesters, planters, machines, mechanization. Large areas of land are required for machines to be cost-effective. Machines require a high input of fossil fuel. Thus, an output would be some pollution. Breeding stock, like seed, is an input to a meat-producing farm. Traditional subsistence farms might use locally available wild stock rather than a specialized line of animals for breeding that would be more typical of a commercial industrial farm system. Here is a list of the inputs that I've just covered. I'll let you study this slide on your own. Take some notes. The primary output of a food production system is the harvested crop, plant or animal. But be thoughtful and flexible. Milk could be an output without having to harvest an animal. Meat is an output. Industrial commercial farms have a high quantity output, but the quality might be questioned if antibiotics or hormones have been used in the production of the animals. People demand both quantity and quality. We are a world of nearly 7.4 billion people. Food is required, but the quality is more difficult to assess. Different societies make different decisions surrounding food quality. More and more people are questioning genetically modified food or food grown using pesticides, hormones, or antibiotics. The organic food movement is growing. Excuse the pun. Consumers are concerned about their health. Health is an output of food production systems. Food production systems have significant environmental impact. Outputs such as excess fertilizer, pesticides, herbicides, fungicides, all of which are released to the environment as pollutants, all of which are agricultural outputs. Food production systems have significant environmental impact. Outputs such as erosion, hormones in the meat, antibiotics in the meat, and air pollution represent environmental problems that come from agricultural outputs. Food production systems require a lot of fossil fuels in the processing and transportation of food. Air pollution is an output of an agricultural system. Here is a list of outputs. I'll let you study this slide on your own. Take some notes. And that brings us to the end of IBESS Soil and Terrestrial Food Production, Part 6.